Hi everyone! Welcome to another great video by ExamSam Study Aids in Media. In this video, we're going to look at some adding polynomials examples, and then we'll have some addition of polynomials exercises. In order to add polynomials, we need to know, first of all, three things. So, our first question is, what is a polynomial? Secondly, we need to know what are algebraic terms. And finally, we need to know what are like terms. Let's go back to our first question. What is a polynomial? Simply defined, a polynomial is a mathematical expression with more than two algebraic terms. What are algebraic terms? Well, let's look at this example expression. A to the second power plus 4a plus ab plus 7. You can have an algebraic term that is raised to a power, like a to the second power. You can have an algebraic term that consists of a number and a variable, like 4a. You can have an algebraic term that consists of more than one variable, like AB, and you can have an algebraic term that is a number. So, moving on to our last question then, what are like terms? Well, let's look at a new algebraic expression here. A to the second power plus AB plus 2a to the second power plus 3ab. First of all, we need to identify anything that has a to the second power. And we can see here we have a to the second power and 2 times a to the second power. For our next term we have ab, so 3ab will be like ab because both of them end in the term ab. Okay, well let's look at some examples then of how to add polynomials together. Looking at our example again, we have a to the second power plus ab plus 2a to the second power plus 3ab. Okay, again you'll remember that a to the second power and 2a to the second power are what we call like terms. So we need to move those two terms together so that they're side by side, like shown here. Looking at our example again then, we have a squared plus 2a squared, which are together, and then we have the term ab plus 3ab. ab plus 3ab, these two like terms are already together. So now we're ready to go ahead and add up our like terms. So looking at that again, here we have our like terms grouped together. And we can see that more clearly by adding parentheses, like we see here. Looking at the next part, we need to bring down the a to the second power and the 2a to the second power. Now remember that any term that doesn't have a number in front of it, you can simply put 1 there when you do your addition. So we're adding 1 a to the second power to 2a to the second power. Looking then at the next parenthetical, again we can move that down, and we can see that ab is equal to 1ab, and then we bring down the plus 3ab. So finally then, we need to add these together. So as we can see here on the first parenthetical, 1a to the second power plus 2a to the second power is equal to 3a to the second power. On the second parenthetical then, 1ab plus 3ab is equal to 4ab. So finally, for our solution, we have 3a to the second power plus 4ab. Okay, that was a fairly straightforward example. Let's look at something a little bit more difficult now. Okay, here's our second example. X squared plus xy plus y squared plus 3 times x squared minus 4xy plus 2y squared. Okay, now how do we attempt to solve this? Well, first of all, for your more advanced problems, it's better really to start off by removing any parentheses, but being careful to pay attention to any negatives. In other words, if you've got a negative in front of a parenthetical, remember you've got to make every single item inside that parenthetical the opposite sign. Okay, here we have a positive, so we can simply move on. Okay, again, remember, remove the parenthetical. Pay attention, though, to any negatives, of course, within the parenthetical. Removing the parentheses, then, we can just move all of our terms down, like we can see here. For our second step, then, we need to group the like terms together. So here's our expression again, x squared plus xy plus y squared plus 3x squared minus 4xy plus 2y squared. Okay, let's start grouping our like terms. We start with the first one, x squared, and we can see that we've got 3x squared later in the expression. So we need to cancel out the 3x squared and move it up closer in the expression, so we have the x squared and the 3x squared together as shown here. Finally, then, remove the cancelled out figure and bring down the new expression as shown here without the cancellation. Okay, so having put the x squareds together, we move on and we can see our next term here is xy. So we need to look later in the expression for any other term that contains xy. And we can see here negative 4xy. So again, cancel out the 4xy in its original position and move that up as shown here on the first arrow. And then finally, you can just bring that down as we show here without the cancellation. For the third step, then, you can put parentheses around each of the like terms in order to do the addition or subtraction. So adding the parentheses here, we can put parenthetical around x squared and 3x squared. We put parentheses around xy and negative 4xy. And we put parentheses around y squared and 2y squared. Then we need to do our addition, so x squared plus 3x squared is 4x squared on the first parenthetical. Doing the operation on the second parenthetical, positive xy minus 4xy becomes negative 3xy. And on the third parenthetical, y squared plus 2y squared is 3y squared. Finally, then, to solve, we can simply state those terms without the parentheses to get our solution for x squared minus 3xy plus 3y squared. Okay, we hope those examples on adding polynomials have helped you, and we want to move on now to the exercises. So here we have 5 exercises. They're placed in increasing order of difficulty. You've got only 20 seconds on this screen, so be sure to pause here to take time to work out the solutions on a bit of scratch paper. The answers and the step-by-step solutions will be shown screen by screen, starting on the next screen. So be sure to take some more time to study those solutions. We'll sign off here now from our commentary, and we'll just say thanks for joining us, and please be sure to subscribe to our channel. Thanks so much.